Internet, welcome back. Today we're going to be looking at 11.2 notes, area of trapezoids, rhombi, and kites. So, a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides of a trapezoid are called the bases, and the perpendicular distance between the bases is called the height. So here's my trapezoid. It's a quadrilateral, meaning it has 4 sides, and with a trapezoid it has exactly one pair of parallel sides. And those same sides here, those parallel sides, are what we call the bases, and we just say that, okay, we have the height here, and they are perpendicular to the two bases. So that's just basically the general idea of a trapezoid. So now let's take a look at area of a trapezoid. Now the area of the trapezoid is half the product of the height and the sum of the two bases. So we use this formula. A equals 1/2 the quantity B1 plus B2 times the height. So let's go ahead and take a look at example 1. Find the amount of material needed to make one side of Brianna's tote. So Brianna's tote is a trapezoid. So what I like to do is I look at my figure. I know this is a trapezoid, so it has one pair of parallel sides. So this is B1, which is 28, and over here that's B2, that's 58, and the height is perpendicular to the two bases, so H is 30. Now all of these sides here are one-dimensional, so I'm just going to write centimeters. So using my formula, A equals 1/2 times B1 plus B2 times the height, and plug everything in. So A equals 1/2 times 28 plus 58 times the height, which is 30. So then your area should be 1,290 centimeters squared. And we have to square this. Since we are in area land, centimeters needs to be squared. Number 2, find the area of the glass used to make the windshield of the car. So this is my trapezoid. And let's go ahead and draw our arrows to indicate that those sides are parallel to each other. That's our height, by the way. So B1 is 72 inches, B2 is 85 inches, and the height is 38 inches. Okay? Alright, so using that formula, A equals 1/2 times B1 plus B2 times the height. A equals 1/2 of 72 plus 85 times the height, 38. So A equals 2,983 inches squared. Okay. A rhombus is a parallelogram with all 4 sides congruent. So if it's a parallelogram, the rhombus, that is, if the rhombus is a parallelogram, that means that opposite sides are parallel, and with a rhombus all the sides are congruent. So this is a special type of parallelogram. Okay, and then one more thing. A kite is a quadrilateral with 2 pairs of consecutive sides congruent. So here is my kite. These consecutive sides are congruent, and these sides these consecutive sides are congruent. And one thing to note about these two things here, okay, the diagonals of these figures are perpendicular to each other. Okay, so I'm going to get into that a little later. Let's take a look at this. Area of a rhombus, area of a kite, it's half the product of the lengths of the diagonals. Okay, so it's A equals 1/2 diagonal 1, diagonal 2, or A equals 1/2 D1, D2. So here's my rhombus, here's my kite. Please know that the diagonals are perpendicular to each other, so they intersect at 90 degrees, okay? So that's going to be necessary when we have to apply, Pythagorean theorem to find, parts of our diagonals and such. So keep that in mind. Let's take a look at some examples here. I have example 2a, find the area of the kite. So since this is a kite, remember the formula is A equals 1/2 D1 D2. D1 is the diagonal 1, D2 is the diagonal 2. So let's take a look. Okay, so how long is this diagonal? I'll call that diagonal 1. Well, that's 8. So diagonal 1 is 8 meters. Diagonal 2, well, that's 15 meters. So easily, I can say A equals 1/2 of 8 times 15. So A equals 1/2 of 8 is 4. So 4 times 15 is A equals 60 meters squared. Okay, again, you're in area land. Make sure that your unit is being squared. So meters squared. Alrighty, let's take a look at B. Cool. This is a rhombus, but note that in order for you to find the area, you have to know this whole diagonal and this whole diagonal. But as you can see, we have a tick mark here and a tick mark here. So that means that this segment and this segment are congruent to each other. So I can go ahead and put 12 here. And this segment is congruent to that segment, so I'll put 10 there. So that means that diagonal 1 over here, it's going to be 24, because 12 plus 12 is 24. And then diagonal 2 over here is 20. So let's plug it in. So 1/2, or A equals 1/2 D1 D2. A equals 1/2 of 24 times 20. So A equals 12 times 20, and that will be A equals 240 feet squared. All right, let's take a look at C together. One diagonal of a rhombus is twice as long as the other diagonal. So I'm going to go ahead and highlight that. If the area of the rhombus is 169 square millimeters, what are the lengths of the diagonal? Okay, so again, let's read this one more time. One diagonal of a rhombus is twice as long as the other diagonal. Well, y'all, do we know how long this other diagonal is? Do we know how long this other diagonal is? Absolutely not. So this other diagonal, I'm going to call this diagonal here diagonal 1, and this diagonal, this other diagonal, diagonal 2. Okay, so diagonal 2 is our unknown. We don't even know what that is. So I'm going to call it X. And then diagonal 1 over here, since it's twice as long as the other diagonal, that's basically saying 2x. Okay, so let's go ahead and figure out the lengths of the diagonals. We have to work backwards here. Using the area of the rhombus formula, it's A equals 1/2 D1 D2. The area is given. It's 169 square millimeters. That's equal to 1/2 of diagonal 1, which is 2x, and diagonal 2, which is just x. So I have 169, which is equal to 1/2 of 2x. What's a half of 2x? Well, that's just x times x. We already know what that is. That's x squared, right? So 169 is equal to x squared. I take the square root on both sides. So x has to equal to 13. Okay, so x has to equal to 13. So I'm not done. I solved for x. How long is diagonal 1? Well, diagonal 1 is 2 times x, right? So 2 times 13, that's, I'm going to move this over here. I need more room. So that's 26, what? 26 what? Millimeters. You don't say millimeters squared because you're going back to one-dimensional land. So there should be an invisible one right here. So 26 millimeters. And then diagonal 2 is just simply 13. Okay, so it's 13 millimeters. And these are your answers. All right, now what we're going to do is look at D, find x, a is equal to 92 inches squared. And you're given this diagonal, and you're also given this diagonal. This diagonal, as you can see, is 22, what is that, 22 inches? And then this diagonal here is our unknown, that's x. So since we're dealing with this type of figure, okay, since we're dealing with this type of figure, that's our kite, it's going to use the formula a equals 1/2 d1 d2. So a equals 1/2 of, let's call it 22 inches diagonal 1, and then this x inches over here diagonal 2. Plugging them in, I get 1/2 times 22 times x. A equals 1/2 of 22 is 11. And I multiply that by x. Oops, you know what I forgot to do? I forgot to replace a with 92. Okay, so now what I'm going to do is I'm going to divide both sides by 11, and x is going to give you a decimal, sorry. X is approximately 8.36 inches, okay? Since we're in one-dimensional land, it should just be inches, not inches squared. Alrighty, so what is the area of the kite? Okay, so remember, since we're trying to figure out the area of the kite, you have to use a equals 1/2 diagonal 1 times diagonal 2. But note here that we don't know how long this diagonal here is, as well as this one. But we're only given the side lengths. So what I need you to do is I need you to recall Pythagorean triples. So I don't want to do the Pythagorean theorem. I don't want to plug everything in. I'm just going to, remind you some things that you need to know. So one of the triples, 3, 4, 5. 3 squared plus 4 squared is equal to 5 squared. If you double this triple, you would get 6, 8, 10. So 6 squared plus 8 squared is equal to 10 squared. Okay? The other thing you need to remember is this. 8, 15, 17. That's a triple. 8 squared plus 15 squared is equal to 17 squared. So I think that's all we need to do, or sorry, not do, that's all we need to know for this problem. But I assume you already know what triples are, and I assume that you know how to apply the Pythagorean theorem, because we are going to be doing the Pythagorean theorem here. All right, we're dealing with the kite. We're only given the side lengths. What do we know about kites in general? Well, the consecutive sides are congruent. Yes, because that's one of the properties of a kite. It says right here, kite is a quadrilateral with 2 pairs of consecutive sides congruent. Okay, so that means that oh, whoa, hold up. I just want to make sure that we're clear on what's going on, because I didn't see this until now. This 6 inches is not part of this. And when I said, oh, these sides are congruent, I saw, oh, that's 10, and this has to be 6. No, that's not supposed to be 6, because these sides are supposed to be congruent. 6, this 6 here is that side. So, in fact, let me do this. I'm going to redraw this figure so it doesn't look confusing. Sorry, it's not perfect, but let's just work with whatever I got here. So this side here is 10, and this side here is 17, and then this part of the diagonal is 6. All right. Okay. So let me go back. Remember, with the kite, all the sides, or sorry, with a kite, consecutive sides are congruent. So this segment and this segment are congruent to each other, and this segment here and this segment here are congruent to each other. And the diagonals, by the way, are perpendicular, like I said right at the beginning when we did this part of the notes. Diagonals perpendicular. So if I were to look at this triangle here, we have a right triangle. You would be using the Pythagorean theorem to figure out this part of this whole diagonal, right? This part here. Well, we already know our triples, right? 6, 8, 10. So we have 6, we have 10. That means that this side here has to be 8. Perfect. Actually, let me use a different color. There you go. And over here, if we look at this triangle, yes, it's still a right triangle because the diagonals are perpendicular, so I can draw that square to indicate, 90 degrees. So I have 8, I have 17, and that means that, what is this supposed to be? Well, we have 8, 17, so that missing side is 15. So that's 15, okay? All right. And I didn't fill these things in. Since these sides are congruent, if this is 10, this has to be 10. And if this side here is 17, that side is also 17. All right. Okay, cool. Now, we have... what do we have here? Am I missing something? Yes, I am. Dang. I was so ready to be done with this problem, but... all right, one more thing. I got to figure out this part of the diagonal, okay? So I have 6, this side, and 10. So this has to be 8. That has to be 8, okay? That has to be 8. Because it's, if you look at this triangle, it's a right triangle. We have 6, 10. That missing side has to be 8, okay? That's a triple. All right. Here we go. Now I have the two diagonals, right? I have diagonal 1. So diagonal 1 is 6 plus 15, which is, what's 6 plus 15? That's 21. And then diagonal 2 over here is 8 plus 8, which is 16. So then A equals 1/2 D1 D2. A equals 1/2 of 21 times 16. I'm going to do 1/2 of 16. 1/2 of 16 is 8. And you multiply that by 21. The area of this kite is 168 inches squared. And there you go. Okay? So, for this problem, either know your triples or use Pythag.